3, and we continue with the presentation, how to get the loads. Out of nowhere. My name is Aleksander Pavlov. Hello. I'll tell you how to get the load out of nowhere from the event programmer. This is who I am, and our infrastructure has been developed for horizontal scaling. The horizontals, the lines, the phone workers, and most of the time it's the limit is the database. No matter how phone workers you have, the database is the only one that you have. So the developers that asking for queries, which are hard to understand sometimes. Why are the queries are full? And sometimes at Facebook we have the list of the presentations, and decided that we are going to talk about the Postgres errors, but I'm going to talk about the errors of the developers. And so they ask, these are the plans of the queries, you do not need to read them all, but this is the small variation of the plan, CTA, appenda, and sorting, grouping, and so on and so forth. This is what has to be optimized. Let's start with simple queries. I'll try to simplify them as much as possible. Specifically in this query, the person decided to keep JSONs inside of the Azure stores. This is the dictionary, the key, meaning, the meaning and the key. So the person tried to save JSONs in the meanings and opens up in the structure, and in external queries he's trying to find the field of token and compares it to one of the parameters. This is sequence quant. So basically you have to look through all of the data in the table, and he had some bad explanations like, well, it's hard to optimize, you can put the index on it because it's inside of the Azure store. But activation is quite simple. So we analyze how many JSONs we have with the following inject token, because this is for the structure of the data. Otherwise, we put it in a different column. It was less than 1%, so utilization was quite good. We had to delete this column, and we put it in some sort of instances. And so don't be shy and change the scheme of the data. As the consequences of this, we sequence data became to nearer. Some programmers took the CTE, common table expression, and they consider it as some sort of the viewer that will need to be set up for a certain original query, but this is not like that. All that you've written to the operators, yes, and then will be given to the fulfilled query to your next query, which is external ones. And the following is the query of scanning of all the documents from the disk, and the external query, the person brought only one document that he needed. Instead of select star, there was some other things, like he implemented all the data in a bad way, but he only had to set up what he was looking for in his query. So out of the thousands of the lines, he had to choose only one. And after release, we had the sequence scan, and we had on Wednesday we had the small optimized queries, and sequence scan just fell down to 0. Sometimes we see the storage of not necessary data, like this, the list of the system news. The person decided when he had the system news, he will, in a separate column, HStore. Some people really like HStore to save up some ID of the users that needed to see that news. There are hundreds and thousands of such users, so you understand that more than 2 kilobytes goes to post table. And at some point there was a case when one user decided, roughly speaking, to stop that addition. And so the user was not part of the news and the Postgres and the MC model. When you update some line, the original line is for delete, and when it's deleted, the new line is being created. So basically, he made the copy of the whole table, and huge data basically has been reviewed. Not only this has been lost, but some other issues happened. This is the query, and a very good example to update the table, to set the new meaning using the initial key. What's wrong with that query? In principle, this person goes to the personal cabinet and presses the buttons, the first one and second one, and he would get the message to calculate some metrics. So the user tried to calculate those metrics, and the result of his calculation in most of the cases was the figure that was saved and stored in the database. So basically we did the update for no reason. So without putting the setting of content which is not equal to new content, then the number of the updates was increased up to 90%. The love for the H store is still there, it remains the same, people like it, and basically people were sold for the H store. This is the example of the query, but to the H store you add one more key, one meaning. Nothing's bad could happen, we think, but the bad thing could be not only SQL query, but also the code which brings this query up. The person who was setting up this query was an alteration and added new IDs. And so elementary have 100,000 users, and this query comes up, and as a result HStore becomes stable. The stable is getting bigger, and it's a natural dynamic process. If we look at the slide, the number of the bytes is growing, is increasing. So the cell was very simple one. So for him, the load for the server, the load was enormous. So the would be that the person at the back end would create a big SQL query and put it in the database. We decided to get rid of that, and that was the code with a huge SQL query with lots of operations coming in, some sort of operations that need to be reviewed through the cycle. I'm not going to talk about the queues. In each iteration of the cycle, we had to take some additional information for each of the operation. And the developer thought, like, why do I need to make these thousands of operations and go to the database to take this additional data instead of make this query before the cycle and to receive all additional info. So this seems reasonable, but this is not reasonable to bring up lots of indexes to one table. So an index and company ID plus group names. So company ID plus group name, and the planner at some point decided, why do I need to read a huge index for company ID plus group name with a huge number of IDs? I have a simple index for company ID, and I will go to that bunch and will bring in the data that I need. And that's what happened. As a result, Postgres reviewed all the operations for company IDs that are like hundreds and thousands and millions, and then they put filter for the group name. But for the group name, there was only 1,000 elements. So the first variant of optimization was quite simple hack. So we reduced the company ID plus group name, and so it turned out that not All of them have the group names, have company's ID. So in each part of the liberation, we had some data that were not needed for all the operations. So the developer thought that we need to bring everything before the start of the cycle, and we decided for its iteration inside of each of the instances we need to bring up the information. As the result, we had this big in turned out into a small index, which consisted only of one element, but the queries were still there. And the last example with HStore, one more time, the same situation with the system news as it was with the system news, but independently some line of the news, some system news, which are attached to the users and the companies, and I needed to bring them with a certain request, query, the system event attached to the user or to the company. So the person goes to the personal cabinet and goes to the company. He needs to see his private messages or the messages attached to the environment where he entered. And then additionally, we use the filter. And in principle, it was done with HStore. You can add gin index, and gin index brings up the bit card, brings back the bit card of the pages, of the rows, of the lines. If it's a slow bit card, is brought back with ID of the pages and is being rechecked and is being taken out. And in the end, it says order byte. So when we say that one of the companies had like thousands, hundreds of lines, all this query and the sorting was brought to the disk. There were more than data than the workman, 16 megabytes, I think, on default. And we decided that even though the plan of the queries is done according to the indexes, the gene index does not allow you to specify which data, which way, which order these data can be read. This is just a byte card. And we wanted to read it by initial code, initial key of B3 to read this info. If this is the example on the slide, as shown on the disk and CT. So we decided if a person goes to the personal cabinet with user ID and chooses the company, we have with the company ID, then I need to work with some events like top 20. And we had a precise look at the queries that's been used this table of events, and we reviewed that and we saw the queries that are practically sort all the events, but happens rarely for our system needs. So we thought that the initial key would be the user ID plus the company ID plus the ID of the event itself. So we get the unique situation, and as a result, this query was running immediately. The previous, one more time. This query was very slow, and this query was slow and it was bad. But some of the queries are slow, but they are slow because it's normal for them to be slow. For instance, the report, we have a service with 3 queries that looked like to generate or to choose something according to the category, make the calculation, and it took it a while because the user himself he picked the timeline when the calculation had to be done, like for the previous year, for instance. We didn't put any limitations on the user. And we found some good thing in our SQL provider. In the line, we said the maximum time for the action is like 1 minute or 10,100 seconds. 100 seconds, the provider would say, I cannot receive the answer from the server or the database. The user would press the button to send the query again, and turned out that in this SQL provider there was a bug, or maybe our arrow, that we did not prepare it very well. So when the user would get the info that I could not get the answer from SQL server, this query was not finished. It was still running. So when the arrow of the timeout happened, the person would press the button again, and the same query was in a line because the first one was still not finished. With a reply of the arrow with a timeout, he would press the button again. There was a competition for these queries, even though they were the same. So we put the statement timeout a session of 100 seconds on this SQL provider stopped stuttering, and if this section was finished in 100 seconds, then we guarantee that in SQL Server this query is also finished. Some of the developers take the operator as a lining query, as in the previous presentation, some said. And some of the developers do not think what they're writing. They say you need to check if there is at least one message about the database. They make the calculation of all the messages for all types of requirements, and then you get in the end the whole list of such tools. And the original query is not being changed, only count is changed to some sort of constant, and for, let's say for 1, and is being used by the operator with exist. And it gets the first portion of the data, it starts, or it can, or has a right to stop the query and say this is true. This message, or only one message, let's say it exists, and it's good for SQL query. So sometimes the business says, I want to know the total number. Let's say there is an email. Do you really need to know how many letters was sent to you by anyone, or in Telegram or contact? And do you really need to know how many messages you got? But some of the persons say, I want to know. So the developer does implement that, and we know our product very well. So when we saw this type of query, we could not recognize where can we bring it into interface. So we decided to look at the model, went to the JavaScript and looked through it. We had the client on the web. Well, luckily we have him on the web. And we didn't see where it is used, so we went to the front ender, we showed the model, the characteristics, and they said, well, in the previous design we decided to delete that, so as if we knew that nobody needs to know how many letters being received, so our design is optimized it by just deleting this query. Sometimes we really need to know the number. We really need to know. For instance, if we need an admin, the person, the analyst needs to know how many clients enter his website, or for some period of time, a specific period of time. For instance, during the New Year, February or January, they just need to know this information from our database. Not only from analytics, but from our database. So we write this query, and this could be slow if you don't have the index for the data, for the date. But the simple date index can wait a lot, and this table itself is not big enough. It's relatively small, so you don't need to create such a big index for this purpose. So the sequence took about up to 5 to 6 minutes. This is our testing data that's been regenerated. And we remember the indice, which is bring block range index, which brings back this weak bit card where the database can be stored.
As a result, there is a recheck, means scanning the whole page in order to double check every piece for compliance with the conditions. Why index is good? It doesn't store no values, no line identifiers. It stores only page identifiers. It splits it into blocks, and from 0 to 100, the values will be on pages 1 to 3, 5, 6, and 8, and so on. And all blocks are done by in the same way. Just for as an example, I took Brin and B3 index, and Brin turned to be much smaller than B3 by orders of magnitude. What was helpful about this index? Of course, it's worked not for 0 millisecond. It returned the pages, then the query grabbed the data. We have 1,300 lines rechecked. But the index is small, it's easy to support, and it works well in places where the values of your columns are physically correlated with the location on your disk. It is good for some log, for user authorization log. You have data, date, and the appends on the disk are being incrementally added. And this index is very good. It fits very well for such columns. I read somewhere in documentation this index is recommended to be done for many columns. If you have a log, a journal, and if you want to filter, it would be really good if your sampling conditions would have the AND operation. In this case, you will see the bitmap AND, and the overlapping area will be really small, and as a result, you will get very fast your data without any additional scanning. You can store less, not only in the index. I touched upon the topic of journals. We had a need to store data for some months, years, quite long, just by dumping into the archive, to the tape. And the designers decided the following way for storage. They made the audit tables with 2 columns, JSON with old data, JSON with modified new data, and of course they started to use the function router JSON, and they stored the whole cartridge with all default values, with all columns which were not changed. And as a result, on the left is the original JSON, which was stored by developers, but such properties as lines, which have null or 0 values, can not be stored, because null or 0 is in the essence the default value depending on your programming language. You don't have to save it just for the sake of space. In the second column you can only store JSON with modified values. It seems that what is bad about storing all values, but the table swells too much, and that's all. And of course, save time for backups and save space. And by the way, the time can be saved even by changing the column of time step type for date type. 4 bytes difference, but developers decided to keep the date in the time step. There's always zeros on hours and minutes and seconds, and you shouldn't select time step for that. And just for the sake of the interest, we changed the column type, and we saved 1.3 gigs just out of nothing. And now you can imagine if you have daily backups, daily dumps to the tape, you can multiply it by the number of days a year, you could have saved hundreds of megabytes. So previously, in the very beginning, there was a bad excuse that index couldn't be attached. Here, the developer had another bad excuse: the index couldn't be attached to a like query, but it could be hanged. The index can, as PGist, can split your regions by subregions. So if you place it on the list, all words with A will go for one branch, with B to another branch. Where could it be applicable? For instance, number of companies, countries, type of services, types of materials can get good use of it. And as a result, this index will store the data. And if you need to do some autocomplete on the website, you can write select name from the table, name like what was inserted, and the percentage in the end. And the planner will not have to tell you that you need to go to the whole pile, whole bunch for the main data. All data which could be started from the lines introduced by the user are already there in this index. But the designer can tell you, I have a reference book where we have to search for the word first, but this word is not in the beginning of the line, it's in the middle of the line. And I want to see the user-like query. And we presented here the gene index. Let's imagine the book and the name indicator in the end. It is just a list, in form of a list of some words, and there are page numbers for every word. And you open the database book, you go to the subject indicator, you find Postgres and page 4, 595. Gene index works in the following way. It says which pages to go. You go there and find manually where is the necessary word Postgres. As a result, the search will work very fast. And just small example that sequence scan are already gone, and the SQL statement works much faster. Here the search goes by not hundreds but dozens of lines. I already mentioned that sometimes we use partial index, and partial indexes are indices which are limited by a condition, and they include only those lines which comply with the condition which are indicated after the syntax of the index itself. A small example: a person had to check whether the company has some operations, some transactions for the last year related to two constant conditions, and I underline them here. So of course it was possible to write a handler which checks the queue and sets ones for the relevant company, and the query would be really simple. But there is another approach. Postgres, in principle, if you have a small number of indices in your table, allows you to create a small partial index which would contain only data which fall under your conditions, and this index will be really small, and this query would start working as index-only scan without going to the pile. And data start to grow. We created the feature, created a small partial index, and that's all. The disk I/O usage by query went down to 0. Here we have a complicated point. We have a number of internal products, and one of them contains the whole story from the developer, and the clients get very complicated conditions of data sortings. There were 5 types of such sortings. Here we have even 8 sorting plus ID, and designers try to optimize where condition in order to get data filtered as fast as possible. If you have index scan, you need to scan data very fast to give them to the user. But if you have very complicated sorting, you need to think whether it would be faster to create an index for this complicated sorting. It will weigh a lot, of course, but nevertheless it would be maybe faster to create this index for this sorting and to decide whether the data which fall under the conditions of sorting be on top of the index, on top of the sampling using this index. They didn't think long. They created this index exactly like this, and the first experiment showed this. Scans went down. The second graph is absent here, by the way, which shows that the query time also went down. Everything started to work very fast. And by the way, here we couldn't match gene index with the search. It produced too much data. Just imagine some chat products, and if someone would make a search for a good day and then such complicated sorting, so millions chats would be found on a good day, and sorting will have no use, absolutely. Next comes union sort. Some designers, some developers believe that sub-queries are cheap, unions are cheap, also CCTE, just write their requests as elegant as possible. They like to write it in a way that be able to retrieve as much data as possible with one script, and then could be proud that they managed to do this. And at some perfect moment they wrote an SQL statement with a bunch of unions. Here we show only 2, and it turned out that in one of the tables there were not just dozens, but much more suitable data, hundreds and thousands. And in the very end, their sorting failed because it fell on the disk. Too much data had to be sorted. All data were combined and started to be sorted. And it all only for the sake to get top 20 elements fitting for this specific condition. So possibly they could have done one separate table, but we came to a solution that we selected from the existing tables only one, and we made it master table, and we started to place data there from other tables, and of course with other categories. There were category columns. And this SQL statement turned to just select star from master table, and everything else stayed without changes, where data is more than necessary and ordered by gdisk. Why does it all happen? Because developers could not know something, they could Google something over Stack Overflow, and after they write the code, their code won't be reviewed, or testers would not test it, or designer would not test his own code under load, or they would test it, but would generate really low quality data. We should proceed from the fact that we do not have initially no data on the machine. We started to make a new feature. We need to generate it and then test it. Moreover, we have to generate different data, and only those data you are going to select. And so we have to think how this data could be used or could be produced in production. sometimes, even when they start testing and understand that the planner starts to make mistake because they wrote too many indices and start to Google how to indicate in progress what needs to be done in the planner. And so planners should create partial indices just for the sake of their existence. In particular, a person makes an immutable function which always returns true but takes a line for the fly to create an index for a table and to indicate this condition with the call for a mutable function. So if you came to a situation when you need some hacks for Postgres to understand what you want to do, so possibly with your scheme, with your code, something is wrong with your scheme or with your code. So you have to redo everything, you should rework it, and you shouldn't be afraid of it. Once again, locally, your query plan can be absolutely different from what happened in production at the moment he was failing in the production. The same can happen with your test environment. There is a special model, auto-explain. If you're not afraid, you can include it in your prod and prod requests which were produced more than 5 seconds. And log analyze, explain analyze will show you this. Next. And if you want to know what happened in production, you can provide logs with prods for your developers. These logs should be maintained very well, otherwise you won't understand why everything was failing in your case. And auto-explain sits in PG Badger. PG Badger eats up logs and creates a very nice and beautiful HTML report for you. These are measures when everything failed, and you should learn what happens. And to do this, to know this, you need some real-time metric. Recommended literature. In Postgres, there is a bunch of indices and their usage on Habra. On Habra, you can find all necessary descriptions of these indices. I indicated 9 chapters, 9 articles. If you don't know, you should read what is explained in principle, and if your designers don't understand what is a database properly and how to write a database in 2 lines at bash in your terminal and how to create a hash index, please, you're welcome for this highly loaded Kleppmann application. He writes there how to make your database on bash. That was all. Thank you very much. Questions, please. Could you bring back 2 unions, where you had union and Linux 20? Is it possible to make limit 20 in the internal selects? No, it's not possible. The first request should contain data for the last year, and the second one for today. And what about eware, also in the same place? So this data should match, should overlap in the lines, not go one after another. They can emerge in different time. For example, in the first table we have a 0 hour, then hour 1, and then again in 0 table, but on the 3rd hour. You should display them in a normal order without missing anything. But maybe vdate condition can be placed there, but maybe it was there. I just didn't show this example for the simplicity. Other questions? If there are no more questions, let's thank our presenter, our speaker, for a very interesting speech.